All right, so for the demonstration, you'll want to open up a brand new ArcMap document. And at this point, you should have already have the ArcSWAT toolbar activated. When it is activated, you'll see these options up here that have SWAT project set up and so on. These are the different tools that you're going to be using to set up the SWAT model. So first things first, you're going to start with setting up your initial project folder. And before I click on that, I'll show you in this demonstration, I'm going to demonstrate how to set up a post-fire model. You'll see here is my data. I've got the elevation information, the land use, a mask, which I'll talk about, and then some other files. So as I'm going through the demo and you'll watch me pull in different layers, it's coming from this folder and you will have access to these files should you want to recreate what I'm doing. Okay, so we'll go ahead and set up a new SWAT project by clicking New SWAT Project. It's going to ask if you want to save your untitled document. I'm going to say no, I don't need it. You'll set your project path. This is going to link to where you have your SWAT data. So in our case, all of my SWAT data that I'm going to show in this demonstration is in this ARSET post demo folder. It will automatically populate everything else that it needs. So you can click OK and give you a message that this project setup is done. So at this point, you now should have a folder. Here's that ARSET post demo. If I open this folder up, you can now see that it's populated with an ArcMap document. This is where your project lives, the interface that you can use. Here are some databases and different files that we'll be returning to throughout the demonstration. Okay. So what you'll want to do next is delineate your watershed. So you're going to click Watershed Delineator, Automatic Watershed Delineation, and you'll get this pop-up. First thing we want to do is read in your DEM. So you open that little folder icon, load from disk, okay. Navigate to where you have your DEM stored. In our case, it's in ARSET post demo, DEM folder. There's the file. I'm going to add it, and you'll see here it is. For the demonstration, I'm using a mask. Now, a mask is not necessary. You don't have to do it, but all it does is basically create a buffer or a zone where SWAT is going to focus. For example, my DEM covers a much bigger area than my actual watersheds. There's a whole bunch of area here that I don't actually need right now in this project. So I'm going to use a mask, which is an empty raster. There's nothing in it. I'm going to open the folder, load from disk. Again, I've got that mask folder. And when I load it in, you'll see what I mean. I'm going to tell SWAT that I only want you to look at where the mask is, and you can ignore that external data. So that's what the mask will do. Next, you'll do a stream definition. This is where SWAT is going to actually use the DEM to estimate where streams are located in your watershed. So to do that, you click DEM-based, flow direction, and accumulation. Right. Get a pop-up, you can click OK. Now, this area suggestion here, you can see SWAT pre-populates it. This has to do with the spatial resolution in your watershed. This is a number that you can play around with. The larger the number is for area, the less or coarser your spatial resolution will be. The smaller the number, the finer your resolution will be. Now, in previous work, I've kind of played around with this number to optimize, what's the biggest number that I have that gives me the best spatial resolution or the finest. So basically, I've seen that if I use 250 hectares as a threshold, I'm able to capture all the streams that I want to capture in my watershed. So I'm going to specify 250, And then under Stream Network, click Create Streams and Outlets. This is going to take whatever time it takes. As it's running, you can see in the background streams. You can see now the actual stream network has been estimated by SWAT, which are the blue lines. Now next, you want to move over to outlet and inlet definition. This is where you tell SWAT where your monitoring gauge is, so that later on, when you do your calibration and validation with that in situ monitoring data, it knows where that data is located in your watershed. So in order to do that, you have to prepare a .dbf file. There's more information in the step-by-step guide about how you make one of these files, and there's also examples of these files in the SWAT installation materials that you'll get if and when you download and install SWAT. In our case, I've provided it, so we're just going to go ahead and add it. You'll get a lot of pop-ups, as you've seen, and the watershed delineation little window was hidden. So now you see this white dot here. That's the monitoring gauge outlet that was just loaded in that SWAT reads. Next, you'll want to tell SWAT where your watershed outlet actually is. For example, in our case, I know that this is Malibu Creek watershed, and I know that down here where my cursor is moving is the Pacific Ocean, and that the watershed actually drains out through this outlet. So I'm going to define it. What it's going to do is give me a little drag and drop box with my mouse. So that's my outlet. Outlet, yes, there it is. Now you'll notice there are a lot of other streams kind of up here toward the right, down toward the left. None of these are part of Malibu Creek watershed. And when I click delineate watershed, you're going to see that the SWAT model is going to recognize that none of those other streams are within our scope of study. So it's going to run and clean up the watershed delineation now. Okay. So now you'll see that only Malibu Creek remains in our interface, which is what we want. The pink is the outline of the watershed, the blue are the different stream reaches, and the purple are the subbasins that SWAT has defined based on the information we've given it so far. Last thing you're going to want to do in this interface is calculate your subbasin parameters. So I'm going to click on that next. Okay. All right. This step is finished. The little window kind of hides, so you have to pull it back out. So you'll see number of subbasins, 45. And if you look under the table of contents, we now have all of these different files that you can go and investigate, but you'll be able to look at toggle on and off the stream reaches and watershed boundaries and so on. So we're going to hit exit because we are done with the watershed delineation, and we're going to save just by hitting the little save symbol. And now you're going to close out of your ArcMap document. I'm going to be following along with the ARSET guide for this demonstration, you will have access to this guide to help you as you recreate these steps if you decide to. But for reference, we just completed steps 1 through 3 of this guide, which were to set up the initial SWAT project, delineate the watershed, and all of the notes here are just going through what I've already said. We just saved the project, which is step 4. Now, there's a note here about backing up the project if desired. If you'd like to back up your project, you're essentially copying and pasting the entire project folder. So wherever you install SWAT or set up this demonstration, to back up a project, you would go to your project folder, which our project in this demonstration is ARSET post demo. You would actually copy this project and then repaste it if you wanted to do a backup. Now this gets pretty cumbersome and it's a lot of files, so it's really up to you, but that is an option and it is noted in the guide. So at this stage, we close the ArcMap document because we move on to step 5. Now, as it says, this is for the post-fire model only. And I want to make a note here that for this fire impacts approach, SWAT requires 2 different models to be made and run separately. So in the demonstration, I am showing you a post-fire model setup. And what I mean by that is that the land cover input in this model has been modified with burn severity, like we talked about in the PowerPoint slide portion. Another separate model will have to be set up, which will be considered your pre-fire model, in which the land cover has not been modified at all with burn severity. And so if you're setting up a pre-fire model, you're going to follow all of the same steps that we're going through here, except for the ones that say for post-fire model only in the guide. So the post-fire model setup has a few extra steps that you will not need in the pre-fire model setup. And this is going to be noted throughout the guide so you know what you need to skip or disregard. All right, so for the post-fire model, this is our land cover that was modified with burn severity data. So because we added these new burn severity land classes, we have to tell SWAT that we did that, because the way that SWAT is wired, it can read in land cover from the National Land Cover data set without us really having to tell it anything. It's already set up for those land cover classes, but it's not going to be aware of these new burned land cover classes that we made. So we have to make it aware. And that's what step 5 is going to go through. So this is where we start to get into the weeds of how those burned area land cover classes were modified. First thing you'll want to do is make a land cover lookup table. It's usually abbreviated with LUC in a lot of SWAT files. And you'll see in the project materials that you are given, there's going to be one already made, LUC post-fire. And when you open it up, it's just a text file. And it's coded that there's a numerical value associated with a 4-letter identifier. And this is what SWAT is going to use to connect the land cover layer that we read in, that we're going to read in, and to the actual SWAT database, so it knows what these things are. And this will become more apparent in the next couple of minutes as we get into the details. So what you're looking at here are a combination of unburned and burned land covers for our study area. Step B here, we're going to go to the SWAT 2012 Microsoft Access database that's inside of your project folder. So our project folder, again, it's ARSET post demo. I open it up. You'll see that there is a SWAT 2012 database that was created. So we're going to open it, enable the content. And here's where we're going to start to fiddle around with some of the presets that SWAT comes with. So in our case, the changes that we're going to make are going to be to the crop, urban, and urban default tabs. These are the different databases that deal with land cover classes. We're going to make certain modifications to our burned areas. So what we've done already is in the land cover raster, we created these new burned area land uses like low burn forest, moderate burn forest, high burn forest. But now we want to actually go in and tinker with some of the settings. Remember, I talked about changing parameters related to fire impact. In this step, we're going to be changing a leaf area index parameter, another leaf area index parameter, these are the LAI ones, and then curve number. And in this guide, it describes to you exactly how those parameters are going to be changed. And as we open up these tabs, I'm going to show you, what it looks like. But just a reminder, your B LAI is going to be set to 1, A LAI underscore min set to 0.2. Curve number is going to be, there's a calculation that has to be done where if it's a low burned land use, we add 5 to the curve number. If it's moderate burn, we add 10. If it's high burn, we add 15 to the presets. You can find more information exactly about these parameters in the SWAT supporting documentation that will be included as part of these training materials. SWAT's got a whole list of documentation that gives you details about what is BLAI, its description, its units, and things like that. But for brevity, you just need to know that those are leaf area index and curve number parameters that we're about to change. So I have already gone through for this demonstration and made all of the calculations and edits so that we can move through this step kind of quickly, but it will take you some additional time. If you start a brand new project in a new study area, you're going to have to sink a little bit more time in than what we're doing today. All right, so the first database we're going to look at is the crop database or the crop tab. This is where the BLAICN and ALAIMN parameters are going to be. So we're going to double click on crop. You can see here a whole bunch of presets that SWAT has for different land use classes it can pull from. As you'll see, there are just so many options. So this can really be expanded beyond our case study in this example to whatever case study you're interested in. But what we're going to do here is add in the burned area classes. All of the presets that are here, these are for unburned land uses, and we care about burned. So in the SWAT demo materials, you're going to have this Excel file that basically is land use update database edits for ARSET. This Excel file has all the preset labels here. So this tab, it gives you a summary. Again, here are the parameters we're going to change. Here's a description of those parameters. Here's exactly how we're going to change them. Here are references for why we made those changes. And here is where to find the parameters within your SWAT model setup. So it's got a little summary. We're modifying the crop database now. And what I've done is already created these brand new burned area classes. You can see the coding matches that text file, that lookup table text file. So this is how SWAT is going to pair the lookup table with actual information. And if we expand crop name, you'll see the new crop names. We've got forest deciduous low burn, range grasses low burn. You've got all our different burn categories. I've gone in and modified that BLAI parameter the way it needs to be. And I'll note here that sometimes, just with the way that the land cover overlays with burn severity, sometimes you get a water land use class that gets reclassified as low, medium, or high burn, which we know isn't relevant to this study. So you'll notice sometimes you'll see water low burn, water moderate burn, water high burn. And for those particular exceptions, no changes are made. We just leave the water parameters. We don't do any of this burn severity modification because it's not applicable. Okay, we keep scrolling over just to show you. Here are the curve numbers that were modified, and here's that other leaf area index parameter that was modified. So it's all already preset, and what we'll do is select them copy, go back to our database. We've selected where we want to insert the new classes. You'll get a pop-up, are you sure you want to? Yes, you do. Great, now you're gonna hit save. So now SWAT has these land uses in its crop database, and it's going to be pulling from it. So we'll move on now. That was crop. We're going to do urban and urban default. We go back to your Excel file, you'll see there's an urban and an urban default. They are exactly the same. I'm not sure why SWAT has this duplicate urban database. It has two different tabs with the same information, but it does. And so we do kind of two repetitive steps here. These are our land use classes that are related to urban uses. For example, residential development, low burn, industrial development, moderate burn, and so on. Here are the curve numbers that were changed. You'll note that there are no leaf area index parameters here because leaf area index is not applicable to our developed land uses. We don't anticipate, or SWAT doesn't anticipate, that there are vegetation cover in industrialized regions. So you're going to copy these, go back to our crop, or I'm sorry, our urban database, insert, yep, hit save, close out. We're going to do the exact same thing on urban default. So let's go to urban default, copy, paste, save. Once you're done with this, you make sure everything is saved and you close your database. So that covers the changes that need to happen in step 5. Again, if you're setting up a pre-fire model and it doesn't have any burned areas, you can skip this step. Now we're going to go back to that ArcGIS interface. So we're going to reopen our project and move on to the next step, step 6. So let's go to our project folder. Here's that ArcMap document. That's where our project is living. Okay. All right. So now we're going to move on to step 6, which is this HRU analysis step. Start with land use, soils, and slope definition. I'm going to use this open file icon, and we're going to read in land use information. So you'll load from disk. You'll get a pop-up asking you if your shapefile is projected. It must be in order for SWAT to read it. So that's something that's noted in the guide. You have to have all your rasters projected in the same coordinate system. So yes, it is in our case. We go to our land use folder. There it is. We're going to select it. All right, you'll get a pop-up. Every time you read in land cover or soil cover data, SWAT is going to do this double check to make sure that the land use or soil cover that you're reading in covers your watershed. And if it doesn't, you're going to have an issue here. But percentage of overlap, 100%, that's saying yes, my land cover fully covers the watershed of interest that we're about to model. So, okay. Now we're going to make sure that our SWAT project can read what we just changed in the database. So for choose grid value, you always go with value. Hit OK. Here are those numbers that are associated with the land use, but you'll see land use SWAT is empty because SWAT doesn't yet know what they mean. So that's where our lookup table is going to come in handy. Click on lookup table, user table. Okay. In our project folder, that's where you read in this LUC post-fire. This is the text file that has the coding. Select. Now you'll see that those numbers, those values, are associated with the 4-letter code. I'm going to hit reclassify. And OK. So now SWAT understands what the different land uses are within the layer you fed it. Moving on to soil, you're going to click on the soil data tab, open up the file icon. For this example, we're going to use the ArcSWAT US StatsGo database. This is the soils database that comes pre-installed with SWAT. Once again, here's your pop-up making sure that there's enough overlap. And in our case, 99.88%, that's fine. Okay. And because StatsGo is already preloaded in SWAT, it automatically populates this reclassify field using STMUID. So I'm not going to change anything. I'm just going to click reclassify. Okay. Now for slope, this is a step where in the example, I've already thought it through and I'll show you what it should be. But in your test watershed, when you do this for somewhere else, you have to play around with the step a bit. The goal is to have maybe 2 to 3 slope classes in which there are equal distribution of slope gradients. So I'll go back to the guide really quick for reference because we're following this guide. For the slope, Malibu Creek is going to have 3 slope classes. The first is going to have slopes between 0 and 9%. The second will have slopes between 9 and 18%. And the third class will be slopes in excess of 18%. And I've done the metrics. And basically, these slope classes are each approximately 30 to 35% of the watershed in total. So each slope class has roughly the same geographic area encompassed, if you know what I mean. So you'll have to set and reset your slope classes. And you can do this step over and over. SWAT's fine with you redefining your land use and slope classes as many times as you need to. But this is something to think about. So the upper limit here for our first class is going to be 9%. For our second slope class, we said the upper limit is 18%. So you'll see now class 1, 0 to 9, class 2, 9 to 18, class 3, 18 plus. SWAT uses this 9999 coding. We're going to hit reclassify. Okay. Now, this little box down here that says create HRU feature class, this is an optional feature. I also have a note about it in the guide. This is something that really should only be used in small watersheds. If it's too big of a watershed, you're going to crash SWAT and it won't work. You'll probably corrupt your project and have to start over. It gets kind of clunky. So in our case, I know that my watershed is small enough for all of these files to be generated. So I'm going to check the box and then click overlay. You can see that the step is working. There's a little progress bar and notes that are at the bottom. Okay, so we finished with this. We'll click OK. We're going to save. It's always good practice to save at the end of each step. If you wanted to check about that land slope, how to know to separate into classes, after you do the HRU analysis step, you'll see that you get a land slope, a soil class, a land use file that now populates. And if you click on the attribute table, it'll roughly tell you informations, how many points in total are within your watershed belong to each class. So you can see that it's roughly equal, almost 3,000 points per slope class. And that's kind of how you can gauge whether or not you're doing a good job at partitioning your slope classes. Okay. The next step is going to be your HRU definition. So what SWAT does is now that it has slope information, soil information, and land cover information, it's going to incorporate all three of these parameters and parse out hydrologic response units, which is what HRU stands for. And there's more information about this in the training as well as in the SWAT material guides, but these are essentially unique geographic areas that share similar slope, soil, and land use across your watershed. You're going to want to define multiple HRUs, which is already the default here. And in our case, we're going to set a threshold of 10% for slope, soil, and land use. And what that means is, in order for a unique HRU to be created, it has to have at least 10% of a land use, 10% of a soil class, and 10% of a slope class. Because there may be areas where a land use is only, accounts for 5% of that geographic area, and we don't want to capture, too fine a gradient, because then we'll end up with way more HRUs than probably necessary. So this is, again, one of those areas where a user can toggle and specify how you'd like to change this. This land use refinement tab up here where it says optional, there is a note in the guide. So we're at step 9 at the moment. Land use refinement is only going to be needed for the post-fire models. Again, I've got a note about it here. In your pre-fire model, you don't want to accept a land use. And what I mean by that, I'll back up. SWAT is going to kick out areas that don't meet the 10% thresholds that you just set. So in other words, if there's a land use, let's say for whatever reason, you only have a tiny bit of forested area in your whole watershed, and it's below 10%, the threshold that you set, SWAT's going to disregard it, and it's going to go with the dominant land use, which is what we want in general. In your pre-fire model, you want the dominant land uses to be represented, not the little niche specialized ones. However, in the post-fire model, where you do have burned areas, you don't want any of those burned areas to not be captured in the modeling. So what you can do is use this land use threshold exemption feature. Basically, you set your thresholds on the first tab, but now you say, I know SWAT, I told you to kick these other land uses out, but I want you to make sure you don't accidentally kick out any burned areas, because I want to make sure all of those get included in the modeling. So that's what we're going to use for this post-fire model. I happen to know which of these codes correspond to burned severity or burned classes, so I can do this quickly, but you'll have to double check and make sure whatever coding you use, you know which codes correspond to your burned areas. So I'll quickly go through and grab those burned classes that we want to exempt. Add. Okay, you'll notice that I left LBWA, MBWA. These are low burn water, moderate burn water classes. Remember, those are not applicable to our study. We don't consider water as burned, so I'm not going to exempt those, but the rest of them will be. For Malibu Creek, we do not need to set elevation bands. This is really applicable to watersheds that have snow melt and seasonality that includes snow and things like that. So that's this step. We're going to click Create HRUs. You can see that there's progress happening at the bottom left here, as well as the progress bar at the bottom kind of right. All right, when it's done running, you'll get a pop-up that says completed HRU definition. You click OK. Once again, I recommend you save at this point. Now, your HRU steps are mostly complete. If you click on this HRU analysis reports, this is really just a summary of the HRUs that were created. If you are curious, you can open it up. SWAT does this nice summary for you where our watershed, this is the area, the number of subbasins, and then it'll break down for you. Here are the different land uses, the area that they cover in different units, as well as the percent of the total watershed area that these land uses account for. So it gives you some nice metrics. These are land uses, here are your soils, here's the slope. Again, you can see, as I was talking about earlier, each of my slopes are about between 30 and 35%. So I know that I have a nice equal distribution of slope classes. And then it continues this breakdown by subbasin. So it gives you a lot of information if you're curious to see how each of the different subbasins look. So close out of that. This is just another little summarized spreadsheet about your watershed that you can scroll through. Okay, close out of that. All right, so at this point, we've covered up to step 11. I'm going to briefly talk about step 12, which step 12 is making sure that you have your climate data inputs ready. These are precipitation and temperature files. For the demonstration, I've already provided these files for you. You'll see them in ARCET demo. Here's what files. PCP are going to be my precipitation files, and TMP are my temperature files. There's a lot of information about how these need to be prepared and formatted. It's all available on the SWAT manual and supporting documentation. But what you need essentially is a header file and then detailed files. For example, PCP, this is the header file. And what it does is it tells SWAT how many stations that have precipitation data, which I have, what is 1, 2, 3, 4, 5, 6, 7, 8. I gave them arbitrary IDs between 28 and 35. Lat-long information for where the stations were located. So SWAT's going to see, okay, there are 8 stations, they have those names, they're at these locations, and then I have individual text files. So at station 28, here is my precipitation from January 1st, 2000. And for my case study that we're showing, we're modeling between the year 2000 and 2020. So I have daily precipitation in millimeters from January 1st, 2000 through December 31st, 2020. And that's all of this record here. There are multiple tools for preparing these input files. The NASA Access tool is one of your options if you would like to use it. That is covered earlier in the training, but not here. For this demonstration, you're already going to be given the files you need. So that's step 12. We're going to move on to step 13, which is actually writing your input tables. So let's go back to our interface. Here's write input tables. I'm going to click on weather stations. So there are some options for your weather generator. SWAT comes preset with a lot of different things here. For a kind of new user, pretty much any option except WGN_user is fine in the United States. If you are outside of the United States, then you have to use this WGN_user option. And there's a lot more detail about this in the SWAT manual and guide. But for our cases, we're in the United States, we're going to just use this first option. In the rainfall data tab, you're going to click on rain gauges because we have precipitation stations. Under this locations table, you click the open file. You grab that PCP header file and you read it in. Under temperature data, climate stations, go back, and now you're going to grab your temperature header file Open it. For relative humidity, solar radiation, and wind speed data, I'm going to be using the simulation options. SWAT has the feature that it will simulate these. If you happen to have some sort of in situ data that you'd like to incorporate in the model, that is an option, kind of similar to the precipitation and temperature. You have to create header files and things like that, but for this demo, it's not going to be applicable. So you'll see simulation is checked for all. I'm going to click OK. Process complete. This little pop-up window does not close out on its own, so you have to close it and then save. Now you'll see that we incorporated the weather station's information. The right SWAT input tables option is now available. This is what we're going to do next. Click on it. All of these input tables are going to provide SWAT with more detail about your specific watershed. So before we delve into those, we're going to select all and click Create Tables so that they'll be written. This pop-up is just built into SWAT. You're always going to get it. It's talking about heat units. You can just click Yes, and you'll see that it starts building and writing all of the tables. And I'll show you what they look like in a minute in the project database. Okay, they're done being built. So once again, you're going to have to close out of this window, click Save. So we've moved on. We are now at step 17. So project was saved. Because we're doing a post-fire model in our demo, we're going to have to do some extra tweaking here. If it was a pre-fire model, you could skip this next step that we're about to get into. All right, so in order to do that tweaking for post-fire, we're going to make sure this is saved and close the project. So now, I'm going to navigate to your project folder. Here we are. We're going to have to make some more changes now. So in this step, we're going to scroll up, modify a couple of databases in the project database. So earlier when we made edits, it was to the SWAT 2012 database, but now we're going to edit the actual project database, which has the same name as our folder, as our ArcMap document, ARSET post demo. So I'm going to open this up. We're going to be modifying some tabs in here. We're going to be changing the .soil and .mgt1 tabs, the soil and the management files. Here are details, again, about what exactly is going to get modified. For brevity, I've already prepared the modifications for us. So you'll have, again, this Excel sheet, you'll have all of this. You'll be able to copy and paste and follow along. But when you do this for your own watershed, you'll actually have to do the calculations and take some extra time for these steps. In the soil file, this is where we're going to modify the USL K factor, which is the modified universal soil loss equation K factor variable. This is related to soil erodibility that we believe changes as a result of fire. We're also going to modify another leaf area index parameter that happens to live in the management database. So we're going to, let's open the soil tab. Here you go. This now has all of the information about our HRUs. You can see subbasin, land use, soil, slope, a whole bunch of information here. What we're going to change, first I'm going to make sure that these are sorted numerically. Starting at 1. And where's our SLK? Let's find it. Here it is. this is the SLK that we're going to change. So go back to our Excel file. You'll see the OID is just a unique number identifier. Land use SLK. These SLKs in the Excel file have already been recalculated the way they need to be for all the burned areas. So I'm going to copy them. Make sure I've got SLK selected and paste. It's going to give you the warning message. Are you sure? You're going to say yes. And hit save. I like to do a quick sanity check. Again, I know my land use codings pretty well at this point, so I know that LB, these land uses here are all low burned classes. I'm just gonna take a quick scroll over. Did they get modified? Yes, they did. So that looks about right. When you do your own project, you can, spend more time double checking all this. No. Sorry, you can cut that accidental paste that I clicked. Okay. So we've modified the soil. Now we're going to move on to the MGT1 tab. There we go. And this is the leaf area index column that we want to change. Move over to here. So here are the pre-modified parameters for you all to use. Yes, save. And again, I know my land use classes pretty well. I just double check some of the burned ones that they got modified. Yeah, that looks, just a quick check, it looks right. All right, so we're gonna close this. Everything got saved, closed. We're gonna not need this Excel file anymore, so I'll close it out. Okay, so these parameters are done. We're moving on now to step 18. It's another step that's only unique for a post-fire model setup. We're going to reopen our project. Let's go back to ArcGIS. Okay. This unique step that we're about to do is going to be to rewrite some files, some input tables. We just changed the soil and management tabs, which means we now have to tell our SWAT interface that we changed it. We want to rewrite those tables to be updated with the new changes we just made. So we're going to use the edit SWAT input, rewrite SWAT input files option. So here's edit SWAT input, rewrite SWAT input files. We changed the dot soil and we changed our management. So you'll select those two and click Write Files. So now the input file SWAT's going to be using to run the simulation have the new updated things that we want. We're going to close and save. At this point, the SWAT model is ready to actually be run. And I'll just put in that reminder that these two last steps, 17 and 18, where we did the changes and rewrote the input files, are not needed in your pre-fire model. So in step 19, we're actually going to use the SWAT simulation option and set up the model run. So first thing you'll click is Run SWAT. Our study period is January 1st, 2000 to December 31st, 2020. This will be different if you have a different watershed in your own study. You can just glance and make sure that it's correct. SWAT has a whole lot of options of what kind of outputs you want it to give. Notably, you can look at model outputs on a daily time step, a monthly time step, or a yearly time step. I'm going to leave it at monthly. That's what I'm interested in. This NY skip is the way that SWAT represents a warm-up period. So when you design your modeling in your own project, you have to set aside some time for the model to ramp up and equilibrate before you actually use any of the model output. In our case, I'm using the first 3 years of the study period. So the years 2000, 2001, and 2002 are only going to be used for model warm-up. They will not be included in any analysis that I did. And so that means I'm going to tell it 3 years. The first 3 years of the period are for warm-up. The model will run during these 3 years, but you will not see any output for it. For the SWAT executable, there are different versions that you can change depending on your machine and setup. I'm going to use the 64-bit release, and that's all I'm going to specify for here, and I'll set up the run. I'm going to pop up saying it's set up. It gives you a chance to make any edits or changes. When you're ready, which we are, we're not going to change anything, you can actually click Run SWAT. And what's going to happen is you'll see a command line interface pop up with the model running. So here it is. You can see it's going to read in our information, and it's going to run the model. I have 21 years, 2000 to 2020. It's going to run for each year. When this is done running, it will go away on its own. There we go. SWAT run is successful. Click OK, and you'll close out of this and click Save. So now your model is set up and it's been run. You've covered that step. Now, there are a couple of different ways you can look at the modeled output. This is, I'm going to emphasize, raw model output. Do not take this output and then go put it in a paper and interpret it. It does need to get criticized, put through calibration, put through validation and all that before you can actually start to do any research or answer any questions with it, but you now have the raw output that you can look at. Option A is if you go to your projects folder, so let's go here, click on scenarios, default, text in and out. There are a ton of files in here. It's overwhelming how many files are in here, but the SWAT manual will guide you about which ones are relevant. But there are, I'm going to sort this alphabetically, there we go. There are some output files. You'll see they're called output, and you can just kind of take a look at them if you're interested. For example, this is the output at the stream reach level. You'll see here's flow for different areas, evapotranspiration, sediment loads, all these kind of rough metrics. It's all kind of fuzzy to read, so I don't recommend getting into those weeds unless you are a more experienced SWAT user. The second way to look at the output is a little bit easier. It's to use the ArcSWAT interface. So we'll go back to SWAT and use the read SWAT output option. There are a lot of different outputs you can look at, but most people are interested in outputs at the stream reach level, at the sub-basin level, and at the HRU level. So those are the 3 most common. We'll check those boxes. Import those files to database. It'll take a minute. Okay, I'm done writing files. And there are some notes here about the different databases and stuff like that. But what this just did was it created a SWAT output Microsoft Access file that you can open up. All right, so yeah, this feature allows a database that's a little bit easier to interact with than reading the individual text output files. These last few steps, these are all kind of optional. It's up to the user if you want to get into it. But there's a way to review the SWAT output. This is called SWAT check. And this is a very rough kind of overview of your model. It's going to do a preliminary assessment of here's what your stream flow looks like, here's what your sediment flow, here's what your nitrogen cycling estimates are. It's very rough, All of this information is just to give you a ballpark of what your model is doing. All the fine tuning is going to be done in your calibration step. So I'm going to show you this run SWAT check now. Here, it's still in the same window, review SWAT output, run SWAT check. The project information is going to be preloaded. You're just going to click examine model output. So it's going to give you just some basic overview. Your simulation length, it was 21 years with a 3-year warm-up period. Yep, it's got this many sub-basins and all that. But these tabs are where you can click through. For example, it gives you a little diagram with estimates. You know, for this model, the average curve number was 81 and, you know, 8.9, and just some basic metrics of your stream flow versus precipitation ratio and things like that. So you can take a look at this. It also gives you some warning messages to say, hey, your groundwater ratio looks a little low, and things like that, to help guide you in interpreting what the model is doing. There's a similar thing with sediment, nitrogen, phosphorus. You can kind of come back to this as much as you like after you're done running the model. So that's going to be there for you. This final step, saving the SWAT simulation, is something I personally choose to do, but you don't have to. Because SWAT is set up that you can go back. Like, for instance, if you looked at your SWAT check and said, oh man, I really want to go change this land feature, you can go back and rerun the same SWAT model that you've set up. But if you want to save the current simulation with all the settings that it has right now, you save the simulation, then you make your changes, run again, and you can save that as a new simulation. And so you get to kind of go back between different simulations and compare and things like that. So as practice, I always save each simulation that I run. Okay, so I'm going to close out of this now. And just for reference to show you, now when you go scenarios, you'll see that there was your default, whatever was last run by the model, plus simulation 1, which is, you know, what we just saved. And it saves all of your outputs. Okay. So at this point, you are done building and running your SWAT model. I'm going to save this one more time. And the last thing we'll go through is this land use update tool. So if you were not doing a fire impacted watershed where you have to build a pre-fire model and a post-fire model, you don't have to do this step D, but that's what we are doing in our case study, so I'm going to show it. Otherwise, you know, if you weren't doing it, you could skip right over to calibration. So to run the land use update tool, this is the tool, if you recall, that tells SWAT to change land use in the pre-fire period to the post-fire period. In our case, the Woolsey fire occurred in November of 2018. This land use update tool is what's going to tell SWAT, hey, I want you to be running our pre-fire model up until November of 2018, and then when the fire happens, I want you to switch and use the post-fire model so that I have one continuous model run that updates the land cover in real time during the model simulation. So this land use update tool, there are a couple of different ways to do it out online, and the resources are linked in the presentation, but I'm going to show one of those specific use cases. So at this point, you should have already set up and run your pre-fire model and your post-fire model. In this demonstration, I only showed you the post-fire, but you would go through and do everything with the pre-fire. You're going to have all of the materials that you need to do the pre-fire model as well. So all of that will be included in your materials. I'm going to close out of this. The reason you already need both of these models to be run is because the code that we're about to use is going to call a specific folder. So let's go to the one that we demonstrated. We just did this ArcSWAT post demo, scenarios, default. this text in and out folder is going to be critical. This is what the code is going to pull from. So the code needs to see a text in out folder in order to work. Here's our post-fire one. Separately, offline, I did a pre-fire model setup. So you're going to see, here's my text in out folder for the pre-fire that's about to be called and what we look at. Okay. Before we get into using this land use update tool, I'm going to use a specific method that was created by this person. So this will be included in your materials, but this is their guide for using their R scripts, and it has links to their GitHub and things like that where you can get the code and kind of review it in a bit more detail. So this is the person who created these files. I am just using them. Okay. So your first step is to open the HRU tab within the project database. So let's go back. Here's our project. Here's our project database. I'm going to go to the HRU tab and going to want to pull these 6 columns are what you need. So you would basically highlight, copy, and paste into an Excel file. Now again, for brevity, I've already done this. So we're going to open up this spreadsheet where I show it to you. So this has all just been copied and pasted into the Excel file that I'm about to show you. When you copy and paste it, it looks, you know, just like regular data in columns. But there are some weird quirks for the code, and I've made a note about it here, that this information actually has to end up in a text file. And when it's in the text file, it has to have the exact formatting shown in this screenshot picture. I don't know why. When I copy and paste it just like this into a text file, the formatting goes wonky. So what I do is I just kind of play around with the formatting in Excel before I copy and paste. If you have a workaround that's better than that, go for it. But in the Excel file that you're going to be provided, you'll see that there are tabs that say post-fire HRU, no format, post-fire HRU formatted. And it'll look weird with offsets and stuff. But if you copy and paste this into a text file, which we can do, let me open a text file, if my computer will let me. Okay, my computer won't let me, so I guess we'll cut that. But if you copy and paste this into a text file, it will now align in the correct column spacings that the code needs. So that's just a little quirk here. But you're going to go into the project database for both your pre and post fire. So you should end up with 2 separate text files. Look at, in this pre-done folder, you'll see I've made them. Here were the HRUs that I pulled from the HRU tab for the post-fire model. And here are the HRUs for the pre-fire model that I pulled from that project HRU tab. And the formatting looks nice and clean the way that it should. So you create these 2 text files. Once you have those text files, you're going to use the first script, which is HRU _all _ land use. That script is included here. We're going to open it up. You can use R or RStudio. In my case, I use RStudio. And let's open it up. The script is set up so that you only define what's in between the user-defined parameter text. So the very first one, you don't touch. You see it's commented, don't change this line, so don't change it. Line 5, this is where you're going to point to the text file that has HRU information for before the fire, your pre-fire. So in our case, Let's look at our file paths. Pre-done, HRU post-fire. That's what the path is. This is, on my local computer to this file. It's an ARSET demo, land use update tool, pre-done. Here's the text file. The next line is going to point, line 6 is going to point to the post-fire text file right here. It's in the same folder. Then you're going to define an output location. So in the pre-done, I've already done it. In this live demo, I'm going to point it to the demo folder instead. I'm going to point it just to demo. So let's go demo. You can name this file whatever you like. I like to call it pre-post fire so that I remember that it has the HRUs from pre and post fire models, but naming convention's up to you. So now that I've changed those things, I'm going to run the code and we should see that new text file pop up here. All right, here's the file. Now, once again, let's click on it. When you open it, you can see that the formatting is wonky once again. HRU does not line up with the number, land use is not lining up with the land coding. It kind of gets thrown off. So what I do is I select all, I copy, I paste it into our Excel file. And I've already kind of done the grunt work of reformatting it. So you'll see here's the HRU pre-post fire no format. This is what was just created. And then on the formatted tab, I've gone through and changed all the weird alignments. So now, if you copy and paste this, let's try. Now, if you copy and paste it, all of the columns are nicely aligned and neat, the way that they should be. So I'll save that and close. So now we don't need this Excel file anymore. I'm going to close it. So we have, let's go back to our guide. So what we've done is just go through steps 2, 3, and we're about to start 4. All right. So for step 4, we're going to use the second R script. What this is going to do is it's going to take this file that we just made that has information about the HRUs, the land uses, what fraction, this HRU fraction, V7, V8, these columns are giving SWAT information about what fraction of the HRU is burned or not burned and things like that. It's going to take this text file and it's going to integrate the output files from your pre-fire model and your post-fire model to create a new text in and out folder. And in this new text in and out folder is where you're going to have all of the configured files that are set up to run SWAT so that it uses the pre-fire land use prior to the Woolsey fire and switches to the post-fire land use after the fire. So for that code, before you run it, you create a folder called new text in and out, which you can see I've already done. And then you put a dummy LUP DAT file. LUP is the SWAT coding for land use update module. So if you open it, opens as a text file. For my case, I put some kind of dummy information in here, but you can see it has this weird spacing. It's just how SWAT needs to read it, so keep the spacing. But It has one entry. It's November 8th of 2018. That's the date of the Woolsey fire that it occurred. And then here's the date again. So this is all going to be included in your demo materials. You can change that for your fire of interest if you're doing it in a new case study. Once you have your folder with your dummy file, this is just details about that dummy file. You're going to open the write text in and out script, which is here. All right, so here, again, you're only changing between the user-defined parameter box that's shown up at the top. Your first input in line 12, you're going to read in the text in and out folder for the pre-fire model. This is all the outputs for that pre-fire, which again, I can show you. Here's pre-fire, scenarios, default, text in and out. You can see that is the correct path. For the post-fire, we'll change it to our demo. So ARSET post demo, scenarios, default, ARSET. This will become post demo, right? SWAT project, ARSET post demo, scenarios, default. Okay, so it's going to point there. The date, this is uniquely modified for your fire of interest. Again, our model starts on January 1st of 2000. We want the change in land use to happen on the date of the Woolsey fire, which is November 8th of 2018. This interpolation, interdate feature is set to NA. It's not applicable to our study, but this feature is meant for other types of land use update. So in our case, a wildfire is a sudden event. It happens one day and then to the next, versus a gradual land use change. So if there was some sort of land management that took effect, you could try and interpolate or have a gradient of land use change, but that doesn't apply here, so it's set to NA. Line 20, you're going to specify an output folder. So it's going to make new in output files. In our case, we're going to point it to that new folder that we just made, which is our SWAT demo, land use update tool, demo folder. And there's that new text in and out. So let's make sure that's correct. Demo, land use update tool, demo. Okay, so it's pointed to the right place. And then last but not least, you need to point it to this text file that was created by the first script. So ARSET demo, land use update tool, it's going to be in the demo folder. Okay, all the parameters have been changed. We're going to run the code. Okay, it's done running. We're done with the ARS portion of this. I'm going to close R. And now, if we go to that new text in out folder, you'll see it has become populated with many, 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 many files, thousands of files. These are all of the details that SWAT needs to run a model. So when we did the demonstration earlier, we went through the ArcSWAT interface. We got to click through and specify all those things. But now when you're running the land use update tool, we're kind of doing it on the back end where you've cobbled together a new model using the land use update tool code. And these are all the files that SWAT needs. So in this new text in out folder, you have everything you need to run a SWAT model that actively changes your land use during the run. So we've completed, let's double check. It's a good practice to do step 9, which is to double check that the DAT file that you need is created. In our case, remember the Woolsey fire is November 8th, 2018. So if I take a look That file should have been created. Here it is. This is the key file that's going to tell SWAT how to switch land use. It's going to have the HRU number and the HRU fraction. This is information that tells SWAT about how the land use needs to get changed at the date of the fire. So, okay, yes, it was created. Good, we're happy with it. Now the last step is to actually run SWAT again with all of these new input files that you just made. What you're going to do to run it is copy and paste the SWAT application file for the version of SWAT that you ran. So if you recall, when we set up, I'll scroll back up, when we were setting up the SWAT run here, when we did this step, I chose the 64-bit release version. So we're going to use that same version. We're going to go to SWAT installation folder, grab the 64-bit release, copy, and we're going to paste it into this folder. And now you're going to double click on that application file, and it's going to run SWAT again. So double click, here it is. The SWAT model is running with all of those new input files. And after year 21, it will finish. And that's it, it's done. So now this new text in and out folder has all of the information that you need. For example, let's go look at the output. See if I can find it. There's so many files. Sort by. Here we go. So now if you look again at the output, kind of raw output, what you're seeing here are outputs for this model that used the land use update tool. So in all of the time periods before 2018, it's going to have output from pre-fire, and then after the fire, it's going to show output for the post-fire model. Kind of bridges the two. It's this folder, this new text in and out folder, that you're going to use when you go on to calibrating and validating the model. So that's not going to be covered in this training, but when you use SWAT Cup, this is the folder that you point to import a new project into SWAT Cup for calibration. I have some information in the guide about SWAT Cup, which is the software you use for calibrating and validating. I've got some suggested papers and information to help guide you as you get started. But since we do not have time to cover that in this session, I'm going to go ahead and close. All of the data that was shown and the step-by-step guide that was shown is going to be provided on the training webpage, so you'll have access to these materials if you'd like to recreate what I showed today.